Right. Hey everybody, I hope you're all having a great day so far. I've had a nice morning actually. The weather is really beautiful today. It's a little hotter, but that's fine. I don't know if I'd say I'm ready for summer because Houston summers are not really very uh, comfortable, but I am a bit tired of the cold, I guess, so. Alright, well let's go ahead and get started, I think. So, I'm still working on the terrain. Oh, I don't actually... Oh, okay, I actually have a bug here. I should use the center instead of flat position. I don't think that actually affected anything, but... And then the get bump height should probably use that as well. Alright, but anyway, so if we look in the game right now, we've gotten smooth lighting and more optimized meshes for the actual hexagon face. So now I need to do the margins between the terrain hexagons. And it should be a little bit simpler because we won't have to deal with hexagon rings. We've got... These are all working. And I actually, between streams, I grabbed this nice little tangent space visualizer which will draw the normals. And I mean, it's not that exaggerated here, but you can see, especially on the stone, the normals don't all point straight up, which makes sense. It looks all about correct to me. If I go back in here, oh wait, in the mod files, this is the wrong folder. And change the bump length to something big. Then we should get more exaggerated normals. Yeah, so now they're definitely... it's almost hard to see with all these meshes. But yeah, they kind of point just straight out from a face, which is what you want. It's not going to be exactly the same because the sample size for the normals is, I think, what is it? It's like 0.15 or something. Or 0.25 actually. That might be a bit big because I think a hexagon is one across, so from here it would go about a quarter of a hexagon. Oh, actually, that might work out okay. But anyway, so it samples a quarter to the east and west, and then north and south, and makes normal based on that, the slopes that it calculates. Yeah, we can see this one's pretty exaggerated right there. It's a strange formation. This is a bit weird. I would have thought it would point more straight outward, but I wonder, maybe I think that this sample distance might be a bit too big. So let's shorten it and see if this gives better results. Okay, well there's still a bit of unexpected normal here, but I think that this might be like an artifact of the terrain mesh having a different sample size than the normals. We could fix it by like just using the neighboring points heights and stuff. But I don't know if that would be preferable to how it works now, so, and it's also would be a bit more difficult. But I guess if for some reason it starts to look weird when we, like it's hard to judge right now because we have this just plain checkerboard texture, so it's hard to tell how I actually want the art to look. But I guess when we get final textures in here, if it doesn't look that good, we can maybe see about having the normals more match how the actual mesh looks, and that would just how we'd have to do that would just be this point, for example, would just average the heights of its neighbors and then figure out the normal that way. Actually, I don't know how that would work with 3 axes, to be honest, because cross product only takes 2. I don't know, I'd have to do some reading on that. But yeah, we'll just go with this for now. So I think I'll bring the bump heights to something more reasonable for now. Okay, so obviously there's holes in between the hexagons, and that's just because we don't calculate the margins right now. The first thing we need to do for that is update these make new points so that they can lerp between 2 and 3 prototypes, because we'll need those for the margins. Might as well do it now. And I think what I'll do is I'll take this code out of here. I think it might be a little more complicated than this, because we could, for example, calculate the normals for each prototype and then average those together. But I think it would look a lot better if we average the bump sizes for each of these positions. So I might make a helper function here that takes 2 prototypes and a lerp. Okay, we really only have to calculate the UV once. Well, no, the stretch values are per prototype, so it will actually have different UVs. Okay, so this is a little simpler. We just would return get bump size, flat position, and then proto A. Oh, we need the lerp as well, so. And get bump size, position, proto B, and then the lerp value. And then for 3, we do the same thing, except I can actually use this, or the triangle average for the floats. L1 and L2. Okay, and then we just pass the two barycentric coordinates. And all this does is it does a linear combination of these values with this formula. So it takes the first, multiplies it by L1, and the second multiplies it by L2, and then the third by the 1 minus L1, L2. So basically what's left. Okay, so I think I'll make another function here to create or figure out the normal given these 4 heights. Okay, oh yeah, I think that's what I should do. Vector 3, make normal, float, x min, x max, y min, and y max. Or, okay, well this is constant, so I can actually make this slightly easier. Oh, well no, because I'd have to get these heights differently depending on prototypes. So yeah, this is the best way to do it. Oops. Oh yeah, and this should be Z, not Y. That way, for all these different functions, we won't have to remember the correct formula for normals. I don't know why. I'm in trouble typing today. This little pop filter for my microphone gets in the way of my keyboard, and I never realize how much I have to glance at it. It's probably a bad habit. Okay, so yeah, this is, I think, the most that we can consolidate this code. Okay, so here, bump A. That is the final position for bump for the point A. So I actually need to figure out the flat position. And that's just flat position plus get distort amount for prototype A. And then I'll need to do the same thing for the second prototype. It might even be worth it. Oh, I can't actually do that here because prototype B could be null. But also it might be worth it that if prototype A and B are equal, that we just call this function instead. That might be a significant optimization. And then if B is null, then we'd also do the same thing, wouldn't we? Okay, that makes it a little easier. Oh no, actually, if B is null, we still use... Oh wait, no, do we? No, this is... I think this is equivalent because if B is null, then we just set bump to bump A and then blend to 1, 0, 0, which is exactly what happens here. I think this might be a mistake because this make new point doesn't because right here I call this make new point, but when we this blend, this lerp actually goes in the middle position when it should go at the last one. Okay, let's see. How'd I fix that? I guess we could just pass the blend, although maybe this vector 3 blend A and vector 3. And so at this point, I don't know if I'm trying to, I mean, it'd be nice to share the code, but then we might want to actually have the blend vector here as well, so we could set this single point to be any of the 3 terrains. Which I guess could happen if some of the neighbors were null. So it might be useful. I just wonder if there's a better way to do it. So yeah, we just pass the blend through, and then this would be blend A, and then else are well, if they're both null, that would be really weird. So I don't think that would ever happen. Proto A is null, then we'll return new point. Proto B, blend B. Okay, so now I don't need this code because we already took care of that. And the blend is also pretty simple now. Yeah, get rid of that normal up. Equals blend A times 1 minus lerp. Plus blend B times lerp. You could also just lerp between the 2 blend things. I don't know what is easier to see what's going on, but this makes it a little more simple to me because we're setting each of these values to this magnitude. All right. Okay, so we have that, both the flat values, and now we need to figure out these. It'd be really nice if I could somehow get these vectors to be common between every variable, but the problem is we're going to call a different version of get bump size. Okay, maybe something like this. Private vector 2, or I guess it'd be a 3. Get bump normal offset, and then we would just return direction times this in case we end up changing. Alright, calculate that. And so then here I would just maybe I should actually pass in the center too. Okay, so now we just call okay, I guess we could actually just roll this into the get bump size actually. So we have flat position and then a vector 3 direction. And we could just set the direction to 0 if we want the actual position. Okay, so let's do that. Flat position plus direction, or I guess it'd be plus equals direction times this. Oh, you have one too many stars. Okay, so now I'll need to add this into these versions. And then just update that. The direction would be the same. Alright, okay, so here I could update this by just changing this to separate arguments and then changing this to ones. Alright, so we gotta do the same thing. Well, actually, I'll just copy and paste it so I won't have to retype all that. Oh, yeah, the position is different for each of these as well because it has to take the different distort amounts. Okay. Well, I guess we'll have one more variable. Oops. And okay, we'll have to have two more here. All right. Oh, okay. I think I might just delete this function. Okay, so this should be vector 3 up. What I need to... Yeah, so the direction here will just be 0 because we want to check at this actual center. I could even fix this a bit by using left and right. And these are just constant values that, well, they're equal exactly to what I am replacing them with. Oh wait, this should be don't know if they have one for Z, which is a little annoying. Yeah, they should have forward and backwards. So I guess I won't do that. I'll just leave that so we can keep these consistent. Okay, so I gotta change this to flat A, flat B. What's it not like? No overload takes 5. This one should. Oh, the LARP value. Okay. Oops, I didn't mean to open that up. So I think I'll just copy these arguments and change the directions because that's the only thing different. Oh, don't need all those extra ones there. We could maybe update these to put it in an array, but I don't really want to create an array for every point. All right, so anyway, this averages the bump size at each position for the prototypes, and so now we would just make a normal from that. So point dot normal equals make normal x min all right. So the position, get rid of all this, I think. The flat position, and then we just got to do this again, but use this LARP to get bump size with vector 3, 0. Okay. Yeah, so if proto B and proto C is null, and there's no point in passing these blend values because there's only 3 types, or 3 terrain indexes, and they're all accounted for, so we can just manually write these out. Yeah, so if B and C is null, then we'll do that. These combinations might not even be possible, but might as well take advantage of it if it ever does come up. So if A is null and proto C is null. Also, yeah, if all the prototypes are equal, we would do this. If they're all equal, then just one. Okay, so if A and C are null, or well, no, that'd be the only time that we would only use terrain B. And then if B and C are equal, or no, I already tested that up here. If A and B are equal, are null, I mean. Okay, so now coming to the possibilities for 2, so we'd only want to use A and B if C equals null or A equals C. What about if B equals C? That would be slightly different, wouldn't it? That's the thing about these triangle points. I think that's why I passed this lerp AB in case we only have 2, because I don't think we can use one of these directly. There's probably some way to like project the barycentric coordinate. Trying to think, how would you do that? Like if we're given these, and then one of these is 0, then this would have to be given equally to the other two, or yeah, I'm not sure if would be given equally or not, is the thing.